All right, hey geometry people out there, this is Coach Lowe coming to you with perpendicular lines, section 1.4. Here we go, we got a lot to talk about. So don't forget what you learned the other day with parallel lines. Parallel lines are always going the same direction. Hang on, I gotta get my colors going in here. Always the same direction, which means they'll always have the same slope. So parallel lines, same slope. I mean, that is like the main ticket there. Okay, I wish I had more time to talk about that. I've reviewed a little bit more, but we've got to press on. Perpendicular lines are going to be much more, well, much different. So perpendicular lines must intersect, and they must also form right angles. We'll be getting more to this soon. But for us with the equations, that must mean two things must happen. You must have opposite reciprocal slopes, or it won't work. And by opposite, that means your slopes must have different signs. One's positive, one's negative. And then reciprocal means you must flip the fraction. So it's a two-part deal, okay? So for example, if you have one fraction that's negative 2 over 3, what's going to be the opposite reciprocal? Well, if you flip the fraction, you have to be a 3 on top, and have to be a 2 on the bottom. If this one's negative, this one's got to be positive. So these would definitely be, and I'm going to throw the symbol at you, perpendicular. That's what it looks like for the slopes. So down here, you got two lines. They're giving you the box, or they're saying perpendicular. But let's look at the equations. I want you to see this. This first one is 2 over 1. This slope right here is negative 1 over 2. And those are definitely opposite reciprocals. You got 2 over 1, flip it. You got 1 over 2, and then definitely opposite signs. So definitely perpendicular. All right, with these two lines, going back to the equations. All right, again, if I didn't say it last time, I'll say it again. They're both solved for y, which means the number in front of the x is definitely your slope. 3 over 1 versus 1 over 3, those are reciprocals. This one's positive. This one's negative, so they're definitely opposite signs. So definitely opposite reciprocals. So these are perpendicular. So that's what we're looking for. And that's going to help us when we come to make the equations. So here we go. Determine the equation of a line perpendicular to y is equal to 1/2 x plus 6, going through the coordinates, going through the point 1, negative 2. I'm going to show you 3 ways, and I just want you to be really comfortable with one of these ways, okay? So pick whichever way you like best. First of all, we got to have a direction. We don't want parallel, so we can't use the same slope. And right now, the way it stands, if you pull the slope right out of here, slope's going to be 1/2. So if you wanted to be parallel, you could use the same slope. But no, we want to be perpendicular. So here comes that symbol again. I want to be perpendicular, which means I got to do the opposite reciprocal. So you're going to flip a fraction, 2 over 1, and since that's positive, you're going to change this to a negative. This is what you got to have if you're going to be perpendicular. Okay, so we're going to use negative 2 over 1. So I'm going to come over here and list my ingredients. So perpendicular slope. I forgot my symbol. We're going to go with negative 2. And I'm not even going to put the 1 under it. I'm going to simplify. So we got negative 2, and I'm going to use the coordinates 1, negative 2. That's what must happen. I gotta have this line going through that point. So here we go. We got the slope, and then this is actually x coordinate, which means you can plug 1 in for x, and you can plug the negative 2 in for y. So there's 3 things you're going to plug into this form. And by the way, this is the slope intercept form. Okay. So let's plug them in. Y goes first, and that's going to be a negative 2 is equal to m's your slope. So we're going to use the negative 2. I'm going to put it in parentheses times your x, which is the 1, and that's going to be plus the b. So we're solving for b. Bring down the negative 2. Negative 2 times 1 is going to be negative 2. Bring down the b. And now we got to solve here, so we got to add the 2 to the other side. Got to do the inverse operation because you're going past the equal sign. So that's going to cancel out, give you 0 equals b. Now going back to the form, most people know that m is a slope, but don't forget the b is actually your y-intercept. So if you want the equation, that means you're going to have to do a rewrite at the end with just the parts that you want here. So going for the mx plus b, we know the slope was -2. That's what we used, x, and then whatever your y-intercept is, you're going to sort of tag that on the end, so plus 0. And I'll go ahead and rewrite it because you don't need the 0. So -2x. Y is equal to -2x. And looking at your slopes, that's 1/2. That's -2. So definitely those are opposite reciprocals. So these lines are perpendicular. All right, that's using slope-intercept form. Let's use this form. This is called the point-slope form. Don't let the y1, x1 fool you because it's going to be pretty easy here. All right, let's bring down opposite reciprocal slope. We'll use -2 again. And we want it to go through 1, -2. And so the 1 in this case will be your x1. The -2 will be your y1. So they're going to go here, here, and again, you're plugging the slope. And so you're going to leave the y and the x. All right. So let's plug it in. So we're going to have y minus -2. That's going to be a double sign. So let's change that to +2 equals the slope, which is -2, parentheses, and then inside you got x minus the x coordinate, which was your 1, so x minus 1. And now, simplify this, let's bring down y plus 2. And then on this side, there's always going to be the parentheses, so you distribute. -2 times x is going to be -2x. -2 times the -1 is going to be a +2, so that's a +2. And again, solve for the variable. Let's get everybody away from the y. So let's subtract 2 over here. We'll put it with that like term. So we have y is equal to -2, and then these 2's cancel out. So -2x plus 0. So we're right back in the same boat. Same answer. So either way it works. So they're very similar. A lot of people like slope-intercept because, again, you're more familiar with it. Just remember that you have to do the rewrite at the end. Once you get used to the point-slope form, it's really not bad because it just takes you right to the equation. So people will get used to that, and sometimes they like that better. Now, if you want to go visual, it works out pretty easy here, but I got to warn you, sometimes it doesn't. And I'm going to simplify this even more. I'm going to start with what's got to happen. This line has got to go through 1, -2, so I'm going to start with that. It's got to go through 1, -2, which puts you right here. So 1, -2. It's got to go through that point. And we want it to be perpendicular, right? So we have to use the perpendicular slope. So imagine going from here, let's go down to, over to the right one. Let's build this line down to, right one, down to, right one. And let's go backwards too. Let's go the other direction. Instead of going down to, let's go up to, and let's go left one, puts us here. Up to, left one, puts us here. So there's your line. And if you're thinking y is equal to mx plus b, you may have exactly what you need right here. So let's think about this. We know the slope that we used was -2x, and remember the b is the y-intercept. So if you track the slope and you track right onto the y-axis and you know that point, well, there's your y-intercept. And so it looks like it's the origin, so that's 0, 0. So you can just say, hey, my b is going to be 0, so that's my equation, -2x plus 0 or -2x. So either way it works. Okay. So I just warn you, again, graphing's great when it does work, but it doesn't work a lot of times as well. Of these two, you really want to be good at one or the other. All right, let's move it on here. All right, so I'm just going to use one method, and I'm going to practice. Let's do the slope-intercept on this one. Let's do the point-slope on the next one. All right, here we go. So again, got to be perpendicular to this line. Solve for y. So that means 4 is your slope here. But we want to go perpendicular, so here we go. Flipping the fraction, 4 over 1 becomes 1 over 4, and a positive becomes a negative, so this is what we're going with. All right, so we're going to use perpendicular slope of -1/4, and we want it to go to the coordinates -2, -4. So again, this is going to be your x, this is going to be your y. So you're going to be plugging in for the y, slope, x, and we're going to be looking for the b, the y-intercept. All right, let's plug it in. So y is -4 equals slope. We're using the -1/4 times the x coordinate, which is -2, and then you got your plus b on the end. Now don't freak out. This works out pretty well. Let's bring down -4 is equal to, remember when you multiply fractions, just go straight across it. You can change this to a fraction if you want to. Straight across the top, so -1 times -2 is going to be a +2. Scratch work over here. Denominators, 4 times 1 is going to be 4, and reduce that. It's going to be what, 1/2? So -4 is equal to 1/2, and then plus b. So to get the b by itself, we're going to have to do the inverse. Let's subtract that over here. So -4 minus 1/2 more. I'm just going to go ahead and write a decimal because it just looks easier. Is equal to your b. That's your y-intercept. So rewrite it. We have y is equal to, slope we used was -1/4 x minus 4.5. And you are done with a hearty check mark. All right, next slide. Here we go. Let's practice the point slope on this one. So we want to be perpendicular to 3x plus y equals 9. First thing you want to, or you should notice, is this is not solved for y. So let's do that. Let's subtract 3x to the other side. So we got y is equal to -3x plus 9. Those are not like terms, so you're stuck with them. So our slope here was -3. We're going, of course, to be perpendicular. So what's the opposite reciprocal of -3/1? Let's flip the fraction. So 1/3, we got changed from a negative to a positive. So that's what we're using. So down here, perpendicular slope is going to be 1/3. We want it to go through the coordinates -3, 1. So this is going to be your x sub 1. This is going to be your y sub 1. All right, let's plug them in. So y minus 1 equals slope times x minus your x. So x minus a -3, double sign. Let's change that to a plus 3. And let's distribute. So on the left, we got y minus 1 is equal to, all right, 1/3 times x is just going to be 1/3 x. And remember this, 1/3 times 3, multiplying fractions, go straight across. You're going to have a 1 times 3 on the top, and you're going to have a 3 times 1 on the bottom, and that will simplify to just a 1. So that works out. And let's solve for the y, so we're going to be plussing 1 to the other side, a little inverse operation. So we get y is equal to 1/3 x plus 2. And here you are done. All right, I got about a minute and a half for the last slide here. Are these lines perpendicular? So if they present this to you, the fastest way to see if they are going to be perpendicular or not is to check the slopes. Okay, are the slopes going to be opposite reciprocal, slopes? They got the red dots on there anyway, so that's what I'd be checking. So I'm going to go for this line first. I'm just going to go, let's hear it. 1, 2, 3, 4. Looks like you're going over 4. That's a positive. You're going up 2. So be careful how you write the slope, though. It's always rise over run. So make sure you put 2 on top, 4 on the bottom. Rise over run, and that reduces to 1/2. So, all right, move to the next line. So from here, let's go down 1, 2, 3. That's your rise. You're going to go over to the right plus 1. So when you write this slope, rise would be -3 over your run, which is 1. So looking at your slopes, are these two slopes going to be opposite reciprocals? And Definitely not.